your operating system is a piece of system software which essentially performs three main functions. And remember that software can be divided into system software and application software. System software is the software which is required for your hardware to operate. Okay, it has very little end user purpose. So there's things like device drivers and antivirus software and compression programs and a whole range of things, your operating systems drivers. And your application software is things that the user typically uses, like Word or VLC or a game or whatever the case would be. And your operating system is the biggest of those three, of those two types of software. And the main function of your operating system is controlling all the hardware and software resources, running applications, and providing a user interface. Okay, those are the three main things that happen in an operating system. And it's important to know the three main features or functions of an operating system. So your operating system controls all hardware and software resources. It decides which programs are run. It manages the storage on your hard disk. It manages your memory. It manages your input and output. So in order for programs to use the printer or the network or whatever, your operating system does all of that. Loading application programs. So it allows you to run application software. So it provides a base for which that application software can run, and it will provide you with some kind of user interface. Your first operating systems were text-based and you needed to type in a bunch of commands. These days they work with mouse and pointers and things like that. Okay. So you can see your user programs run on top. This is what's classified as your operating system. So you've got your application software, user programs, and your hardware over here, and your operating system allows your user programs to utilize the hardware. And immediately below your application software is your user interface. That's how you interact with your operating system. And then you've got system calls, which is essentially allows your application software to do particular things with the hardware. And then you've got the features of your operating system over here. So it controls programs, input, output, your file system, communications, error management, resources, auditing, security, and that all interfaces with the hardware. Okay. So one of the biggest tasks of an operating system is process management. And process management essentially means which program is allowed to run, how long is it allowed to run for, when is the next program going to be run. So it controls what is able to access the CPU and the RAM. Okay, so which program is actually running at a particular time. Now, modern operating systems do this in various ways, but essentially they all implement multitasking. Now, multitasking means using more than one application at a time. And the way that it does this in general is divides the CPU's time into small little slices. And it switches between all the running programs very quickly. So it may seem like you're playing music and writing or typing a Word document at the same time. But in essence, the operating system is only processing very small parts of that program. But it does it quickly enough that it seems like it's running, those two processes are running simultaneously. So your operating must ensure that each process gets enough CPU time in order to perform its function, that it gets other resources that it may need, okay, so other hardware resources, printers, network, communication, screen, RAM, storage space on the disk, and that the CPU is being used as efficiently as possible in order to carry out as many tasks efficiently as possible. And you can obviously imagine that this is quite a complex task. And the way that it works, and this diagram shows it at the bottom over here, is there is a queue that's running. We can just zoom in here a bit. So you can see there are a number of processes which need to be executed, okay? And sometimes a process ends up waiting for some input from the user, okay? Like the programs you write, if you try and read in something from the user, the process is waiting. It can't continue until you do that. Or it's waiting for something to come across from the network or to be loaded from a disk or whatever the case would be. So you may have a bunch of processes which are waiting, okay? When they've received from one of the peripherals or whatever they need, they go into the ready queue. And all the processes in the ready queue will get a chance to run. Okay? So that process will be run. It will either then be completed, or when its time is up, or it starts waiting for another piece of information from the keyboard, or needs to output something, it'll go to the waiting queue. Okay? When those processes have what they need, they'll go back into the ready queue, either complete or go back into waiting. Okay? And that is the task of a process scheduler, okay? Or just abbreviated as a scheduler. So it schedules what tasks need to be run, what state they are in, are they ready to be executed, are they waiting for something, and your operating system will manage that entire process. So another important part is I/O management, so it's input-output management, and that's largely done by the operating system using something called interrupts. And interrupts are signals which are sent to the CPU when a particular event is triggered. So for instance, we can have software interrupts. So a particular program can generate an interrupt for the CPU to say, I need attention right now. So if an error message pops up, that should interrupt any other processing so that you can see that it's an interrupt. So for instance, when your battery starts dying on your laptop, the power control software creates a software interrupt and says to the CPU, I need your attention right now, and I need you to display this error message. Okay. So the interrupt can come from a piece of software. So if something goes wrong or needs to alert the user to something urgently, the software can send an interrupt to the CPU and go, stop what you're doing and do this right now. We also have hardware interrupts, and hardware interrupts are incredibly important. And what they are is each particular port on your computer, so every particular peripheral will have an IRQ number, an interrupt request number. And what it does is it can interrupt the CPU, and it can say, right, I am your network card, okay, and I have interrupt 11. So you need to do this right now. And the CPU will do it unless there's an interrupt with a lower number waiting. So your system timer is interrupt 0. Okay, it trumps everything else. And your system timer obviously keeps your clock ticking over in your computer. So that will interrupt quite often, and that's interrupt 0. But there are other things, like your keyboard is interrupt 1. It's quite important that the user can keep outputting stuff. Audio is 5. Traditionally, it could have been 7 as well. So whenever hardware needs some attention, it will send its IRQ number to the CPU and say, this is important to do this now. You can imagine what's more important, that your music keeps playing or that you're able to type something on a keyboard. So the keyboard is quite a high interrupt. You have to be able to kind of communicate with your computer. So that will have quite a high interrupt number. And those are hardware interrupts. So they are assigned by the operating system in order to make sure that your hardware can keep operating regardless of what other software is running on your computer. So that's interrupts. Memory management is also quite important. So remember, we had process management, which manages the process. We've had interrupts, which manages the hardware and how it communicates. And your operating system also manages memory. And the most important thing an operating system needs to do is to make sure that each process that's running has a separate memory space. Okay? So in other words, MS Word has its own memory space. Your VLC has its own memory space. Your browser has its own memory space. Because you can't have software interfering with other applications' memory space or allocated memory space. And that's quite an important concept. Otherwise, anyone could just write an application which messes with any part of the memory and stop another program from working. So at any particular time, your RAM stores your BIOS programs, your interrupt tables, the core of the operating system called the kernel, and all other running application programs. So your RAM has to be able to store the data and instructions which are currently being used. And you can imagine that your operating system is an important part of that. Now, there is a very special kind of memory that you need to know about, and that's called virtual memory. Now, virtual memory is quite widely used, and it's quite awesome. It does have its drawbacks, but generally it's something which is quite good. And what virtual memory does is it sets aside a particular place in secondary memory to use for the overflow in primary memory. So let's say, for instance, you've got 8 gigs of RAM, and all the programs that you're currently using have 8 gigs of RAM. They're using up all your physical RAM. Then you click on another program which you want to run. There's not enough space in RAM. So what your operating system will do, it'll look in memory and it'll go, okay, which program in RAM is not currently being used or is not used very much, okay? It might be the word processor that you have open, but you haven't used in a while. It will then take that primary memory for the word processor and all the details and data and instruction which is stored for that, and it will put it on the secondary memory. And then it'll put whatever you want to load into primary memory. Okay. So that whole process is sitting on secondary memory. Now, it can't be accessed directly from secondary memory. So when you click on it again to open it up, virtual memory will chuck something else out of RAM onto secondary storage and load what you need to use into primary storage, that word processor, for instance. So RAM still stores what you're currently using, but it can be paged out. These are called pages. So there's a page in primary memory which is stored on secondary memory, okay, until it's needed again. That allows you to have more programs open than you have RAM available. So it basically gives you more RAM in a weird kind of way. However, if you only have 8 gigs of RAM and you try and load a program that requires 16 gigs of RAM, you're not going to be able to do that, because you can't have half that program sitting on secondary memory and half of it in primary memory. So it doesn't give you more RAM, it just makes your RAM usage more effective. What can happen is thrashing. In other words, you have too many programs that you're using simultaneously and they keep swapping out from primary memory to secondary memory, and you can't really use any of them effectively simultaneously. But generally, virtual memory is a great way to manage that. The other thing your operating system does is I/O system management. So it's called device management, and we make sure we can control different pieces of hardware, and we can make sure that the data can get to and from that hardware efficiently. And one of the most important ways that that's done is a device driver. Now, a device driver is the software that your operating system needs in order to make use of a particular piece of hardware. So your printer driver, for instance, will be specifically for Windows. And it will tell Windows how to use your printer, that actual physical hardware. Without it, you wouldn't be able to do that. Okay? So what is required is a driver for each piece of hardware that you have. And a lot of your drivers come with Windows. It will have drivers for the most common pieces of hardware. But a driver is a piece of software which allows your operating system to communicate with a piece of hardware. You can imagine, if you write an operating system, you can't make it compatible with all hardware. You're going to need third-party software called drivers, which you're able to install to use some random piece of software, your very expensive gaming mouse, or some audio recording software, or whatever the case may be. Okay? You're going to need a special program, and that program is called a driver. And it's written for a particular piece of hardware to work on a particular operating system. You may have heard the term plug and play. Now, plug and play is really just the automatic installation and detection of a device. If I ask you, does plug and play still need a driver? The answer is yes. The only difference is the driver is installed automatically. And in order for a device to be used, it needs a unique IRQ. We talked about interrupts a few minutes ago. And it needs a piece of memory. We call it an I/O range. So it needs an interrupt and a piece of memory. So the process of plug and play is the PC is switched off. You plug in your new hardware device. When the PC boots up, it automatically detects that there's a new device there. And it assigns it an IRQ and some memory, and then requests to install the driver. Okay, that may happen automatically, or you might need to point the operating system to that driver. So we plug it in, we switch the computer on, it detects the device, it assigns it an RQ and some memory for it to use, and then the driver is installed. So that's plug and play. We don't need to switch off computers these days because we have something called hot plugging. And hot plugging means that the computer doesn't need to be turned off in order to trigger this plug and play. We can just plug it in and the computer automatically detects it and then follows it. USB is a perfect example of this. You can plug in USB devices, your computer will detect them, assign them an RQ, some memory, and it may ask you for a driver depending on the device. I'm sure you've all experienced that. Okay, so that's hot plugging and hot swapping. We then go to file management, and file management once again means storage management. So you take for granted that you have these folders and these files on your flash disks or your hard disks, but your operating system keeps track of all of that. Okay, your operating system keeps track of what the folder's name is, where it's stored physically on the disk, which folders and files are in that folder, in those folders, which files and folders are in that folders. It keeps track of the permissions, who's allowed to access it, is it hidden, is it a system folder. It needs to keep track of every single piece of data that's stored on your hard disk and structure it accordingly. So if your data is stored in 4096-bit blocks, it needs to know that when it saves a new piece of data, it needs to write it in blocks of those size. Or is it encrypted? Okay, if you use NTFS or your later versions of Windows, you have the option of encrypting your data. So it allows you, it keeps track of when you create a file, when you delete a file, if you're going to move it, where that's mapped to, or using FAT16, FAT32. It's keeping track of all of that information about the files on your computer, and secondary storage and primary storage.